Hello everyone, so today we are going to do lab 122. So it's about the energy conservation or the conservation of the mechanical energy. Alright, so let's take a look at the experimental part of this lab. So here is the movie. Alright, so as you can see, the experimental part is very straightforward. Basically, we have an inclined air track here, and we have two flow gates, and of course we have a glider. Alright, so there is no friction between the glider and the air track, and when the glider goes through the flow gate, these two flow gates are able to measure the velocity of the glider. So today's topic is about the energy conservation and the mechanical energy. So let's look at the definition of mechanical energy. So mechanical energy has two components: the kinetic energy and the potential energy. So let's start from potential energy. So the potential energy is basically depends on its position, or depends on where you put the object. For example, we have this object here. If the position of the object is higher, which means when you let it go or when you drop it, there is more energy to release. So we can say that um, if we put an object higher, then this object has more potential energy. So let's look at the equation. So this potential energy um, depends on the height of the object, and depends on the mass of the object. All right, so I think that this part is very straightforward. So basically, just the height, the mass, and this is the gravitational constant. So it's h times m times g. That will be the potential energy of the object. And kinetic energy is determined by the velocity of the object. So if the object moves faster, which means the kinetic energy is larger. Alright, so the equation to calculate the kinetic energy is 1/2 times m, the mass of the object, times v squared. So this v is, is the velocity of the object. Alright, so let's look at this object. When the object or the glider, this is the glider and this is the first flow gate and this is the second flow gate and this is the inclined air track. So when the glider goes through the first flow gate, the flow gate is able to measure the velocity of the glider, which will be v1. And you can also measure the height of the glider when the glider goes through the first flow gate. So we have h1. All right. So and we can also measure the mass of the glider. So that will be the m. All right. So we have v1, we have h1, and we have m. Then we can calculate the kinetic energy when the glider goes through the flow gate 1, which will be 1/2 times m times v1 squared. And the potential energy when the glider goes through the first flow gate will be h1 times m times g. Okay, so this is the kinetic energy and potential energy when the glider is in flow gate 1. And for the same reason, so when the glider goes through the flow gate 2, so the kinetic energy, only difference in kinetic energy will be the velocity has been changed. So the kinetic energy will equals to 1/2 times m times v2. This v2 is the velocity when the glider goes through the second flow gate. And this h2 is the height of the glider when it goes through the second flow gate. So you can measure v2, the flow gate 2 will measure v2, and you can measure h2 So you can calculate the kinetic energy and potential energy when the glider goes through the floodgate 2. And what is the conservation of mechanical energy? The conservation of mechanical energy is that if there is no friction between the glider and air track, then the kinetic energy plus uh, potential energy will be a constant number. Okay, so which means the K1, the kinetic energy plus this H1 mg will equals to K2, which is 1 half times m times V2 squared plus H2 mg. So this is the energy conservation. Okay, so from floodgate 1 to floodgate 2, the potential energy is decreased, right? Because the height of the glider is decreased. So because the floodgate 2 is lower than floodgate 1, so the H2 is smaller than H1, which means the potential energy at floodgate 2 is smaller than the potential energy of the glider at floodgate 1. But kinetic energy is increased. So because the V2, the velocity at floodgate 2 of the glider will be larger than the velocity at floodgate 1. So the V2 larger than V1, so kinetic energy at floodgate 2 is larger than kinetic energy of floodgate 1. Alright, so so basically you have a smaller at the floodgate 2 you have a smaller potential energy, but you have a larger kinetic energy, and at floodgate 1 you have a larger potential energy but have a smaller kinetic energy. So what you are going to do in the data analysis or in your calculation part will be you can measure the H2 and H1, V2 and V1, and also you can measure the mass of the glider. Then what you have to do is to verify that H2 times m times g plus 1 half times m times v2 squared equals to h1 times m times g plus 1 half times m times v1 squared. Okay, so we have five measurements: h2, m, v2, h1, and v1. So let's look at how to measure this. So the first is the measurement of the mass of the glider. So the readout is going to be 290 gram, which is 0.29 kilogram. That will be the m. And so here we're going to measure. You see these two plots, so you can measure the height h2 and h1. I'm sorry, here is the h1 and h2. The upper plot is for h1 and the lower plot is for h2. Because the height is a relative value, so you can because the measurement is start from the table, so you can just use the readout directly from the ruler. So for example, this one is somewhere between 26 to 25. You can use this line as the reference line. So somewhere between 26 and 25. And H2 is somewhere between 22 and 21. So you can do your own readout, and that will be H2 and H1. So keep that in mind. H2 is the smaller one and H1 is the larger one. And here is the data you need. So we don't care about the time in gate 2 and gate 1. We only care about, so this column is V1, the speed in flow gate 1, and this column is V2. So basically, you repeat, basically you have three trials data. So you can verify this equation for 3 times. So all I need for the lab report will be verify this equation using these three data sites. Because there are only one H2 and one H1, so we can keep the H2 and H1 fixed and use three different V2 and three different V1 to verify this. And that will be all you need to do for the lab report. And that's it. And just do the part one. So if you have any questions, you can just email me. Thank you.